So we want to look at how can we make working with classes easier and safer so our data is protected and it's a little bit easier instead of having to have all these class definitions at the top of our file. So one of the things I've done is I've taken our class definition right now and put it into its own separate file. It's in a file called dice.py. So that's the first thing we're going to do. And that's a pretty common thing, actually, is anytime we have a class definition, we're going to put it in its own separate file. Then we go and have a program to run, something like this. We're going to say import dice. And we've used import before to import external libraries. Well, now we've created a file, a class definition that we've created, and we're importing our own. But we want to do one more change to our dice.py file first. And that is we want to protect our value attribute. To do so, I'm going to put 2 underscores in front of it. Now, you might say, well, what is that going to do really for me? Well, what that does is it makes it protected so that outside functions and things like that cannot access it. It hides that value for us, not just because it has 2 underscores in front of it. That's what tells Python to not allow access from another source. It has to be within our class. So every time I see value, I'm just going to put 2 underscores in front of it. That's helping with that encapsulation. Inside dice, you notice I have the import dice and I have my main function. In order to do this, what I've done is I need to create an instance of dice. So I have dice.dice, and dice is my external file, my Python file, and then inside of it I could have multiple classes, so I need to specify which one I'm creating. .dice. Notice that it is capitalized because that is how our class is defined. Next thing we're going to do is we're just going to do a for num in range and then roll it so we can get some different values real quick. When I roll this, you can see I have a list of 25 different values that have been returned. That's just giving us a nice little roll that we can work with. I can make this a little bit more complicated if I was interested. For example, let's say I was playing a game like Yahtzee where I have 5 dice, and so I have 5 different dice. What's nice about this is what we're going to see real quick when we run this. Notice that each dice gets their own roll, and then we're going to print them out. When I roll these, notice that each dice gets their own values. So all of my data being encapsulated inside of its own object means that it's not dependent upon other objects. This data is going to be independent of any other dice object. So when we rolled 25 times, 5 dice, we got 5 different dice that we're rolling. Of course, if I wanted to, I could also put my dice in a list and then access each individual element. This application is just a little bit more complicated, but does the exact same thing as what we did before. There's a little bit of difference in this, and that is that we've also defined, we've printed out what the dice object is. And we're going to show you how to change that in just a minute. But the dice object by default, or any object, is going to specify what object it is and what the memory address it's at. And so that's something we're going to want to look at, is change that default print statement in just a second. So let's look at a couple things that we can modify to help make our dice more user-friendly. We've already talked about the print statement, and we're going to look at that in just 1 second. So to change the print statement, what we're going to do is we're going to create a new function. Def underscore underscore str underscore underscore. Anytime we print and then we put an object inside of it, now we're going to get a different value. Let's show you an example of how this would work. Let's say what I really want to print is the value that I'm storing. So I'm going to say return self dot underscore underscore value. However, that is a numeric value, not a string, and we want a string value. So I'm going to convert this implicitly to a string by saying str and then passing in my number. That converts a number to a string. Now, when I call my get value and then I say print and then the object, notice it gives me the same values. That's because I've updated that print statement. So it's just a real quick way that you can verify that. Now let's look at one other major change I want to do. One of the key reasons for using classes is to make them more flexible. Well, a 6-sided die is a very common type of die, but it's not the only type of die. I might have other sides that are available to me. A 20-faced die is a pretty common one as well. Well, I could specify a max number of sides, and then I could get a roll that's going to give me between 1 and that maximum number of sides. It's really easy to do this. Inside my init, I'm going to say comma after self and say sides equals 6. And what this does is it gives me a default value for side. If I don't pass it a value, it'll use 6 as a default. And then instead of just specifying random int 16, and specify self dot underscore underscore max sides equals sides. Then where I get my random numbers between 1 and 6, I'll replace that between 1 and self dot max sides. I'll run my first program since it's a little bit smaller and easier to read on the screen. And you'll notice it gives me the same values just as I'd expect. However, if I create a new one and specify, for example, sides of 20 and run this program, now you can see that while it works by the default with 6 sides when I don't pass any values, it also works when I pass in a value of 20. And now I'm getting a wide range of different numbers, all the way from 1 all the way up to 20. So it gives a lot more flexibility, allows me to do more with my class definition.